given that we have a function, state the domain of the function. So you can see this function, you have denominator. So first of all, denominator not equals to 0. X will not equals to -1 to find its domain. And then beside that, we have a surd function. So under the surd, it have to more than equals 0. So x squared more than equals to 0. So x, whatever value of x you substitute here, it will be more than equals to 0. So this x will be all the real number. You can accept any number because as long as you substitute into the x, it can more than 0. If you want to see this, it will be like this, more than 0. So you can accept negative infinity up to infinity. So combine these two conditions, the domain of the function only will be negative infinity until -1 not include. That's all. So from the surd function here, we don't have any condition of the x, but from the denominator, yes. So from there, we can build out our domain. Then secondly, we need to find our vertical and horizontal asymptote. To find vertical asymptote, we are going to calculate limit as approaches 1, -1 from the left hand side for the function, and limit x approaches -1 from the right. So as we substitute -1 into the function, we get surd 3 over 0. So here we'll have infinity. Then to get this, whether it is positive infinity, we're going to test. So -1 from the left hand side, we test x equals to -0.999. So we try to press calculator for this. So you can get this is a positive infinity. And then for the right hand side, substitute -1, it will be surd 3 over 0. So therefore it is infinity also. From here we're going to test the right hand side. So we test x equals to -1.001. So you can get this result, it is negative infinity. So from here, we know that x equals to -1 is vertical asymptote, because you can see the result. As long as you can get the result positive infinity and negative infinity, means this point of x is vertical asymptote. Then we continue for the horizontal asymptote. Horizontal asymptote, we're going to calculate the limit as x negative infinity. So when I substitute the infinity, I get IDF, infinity over infinity. So what can we do is simplify this by divide the highest power of x. So we divide power. You can see square root of x squared. So square root of x squared, actually it is equals to modulus x. It can be positive, it can be negative. So for x approaches negative infinity, under the surd, 3x squared over x squared. So on denominator here, without surd, x will going to divide by negative x. Then we can simplify. We evaluate our limit again. So this is surd 3, this is -1, this is -0, so therefore it will be -3. Then continue, we're going to calculate limit x approaches to positive infinity. As I want to simplify, divide the highest power of the x, square root of x squared. So out here we'll divide by x, because our x is approaches infinity. Then you simplify, you get this one, 3, 1 over x. Evaluate your limit, 3. So this is positive. Therefore, from here, we can notice that y equals to negative 3. Y equals to 3. They are horizontal asymptote. Then after that, we're going to sketch this function. So first of all, we're going to sketch all the asymptote. As your asymptote here, we can see x equals to -1. You have x-axis, y-axis, and then you have two horizontal asymptote, which is y equals to 3, and another one, y equals to -3. So come with the graph here. When x approaches -1 from the left hand side, our graph going up. So our graph is going up here. And when -1 from the right hand side, our graph is going down. Alright, so we have some mistake here. Just now I inverse these two parts. This is from the testing, this is from the left. So this one supposed positive. This is testing from the right, supposed to be negative. So that's why these two will be opposite. And then when it go to the x approaches -infinity, go to the left hand side, graph approaches -3. So we can see here our curve going to the left hand side approaches 3. So when I want to draw the graph approaches to the positive infinity, will be approaches asymptote 3. You can notice that it might intersect x-axis, y-axis. So therefore, I want to find what is your y-intercept. Y-intercept is when x equals to 0. Therefore, it is 0 over 0 plus 1. So it will be 0. So here will be the intersection point. Therefore, this graph you need to intersect, go to the intersection point first, then approximate. So here will be our concern. Will you go approximate? How will be the curve? So how will be your curve to approximate your cert 3? Alright, so it will be approximate your cert 3 like this. If you want to do your concavity down like this, it will be very weird. Alright, so either it will be concave outward or concave downward. If you want to do concave outward, it seems like you want to intersect with your asymptote. So that's why we will do approximate. y equals to cert3. So lastly, we just label our function. It is equals to cert3x squared over x plus 1. So make sure you label your graph. So the graph here is supposed to be labeled here 0. So we look at the marking here. First mark, domain, will be just 1 mark. Finding your vertical and horizontal asymptote. So finding -1 from the left, finding -1 from the right, getting your answer x equals to -1 is a vertical asymptote, and then finding your horizontal asymptote from -infinity and positive infinity, getting these two values as horizontal asymptote. Then there will be your 4 marks. Then when you do graphing, firstly we want to see your shape. Then we want to see your asymptote. Then lastly, we want to see all label. So make sure you label your x-axis, y-axis, asymptote, intercept, and function.